Guys, welcome to my channel Study Up. Today I will discuss about the third part of the light, which will be very helpful for you. After this completion of this video, you will be able to give the answers. What is the spherical mirror, convex mirror, concave mirror, and what are the uses of different mirrors in case of rear view mirrors. What is the actual mirror we using in our daily life, and how we easily determine or distinguish whether it is a plane mirror or concave mirror or convex mirror without touching it. So many things, and number of also images form, the formula, how to find out how many numbers of images will form when two plane mirrors are kept in particular angles, and so on. Okay, so let's start. So in part of video I have discussed so many things, that is the real image, virtual image, difference of the real and virtual image. Real means inverted, virtual means direct. It can be cut off in the screen, it cannot be in the screen. This is the difference I have already told. And also the number of images formed in case of the mirror placed in different angles. Say parallel picture that 90 degree, 45 degree, whatever may be the angles. The number of images you can also find out by applying this formula. Number of images is 360 by theta minus 1. If theta is 50 degree, so there will be some value of n. If in case of value of odd number or even number, so the number of images will be the n minus 1 in case of even number. Okay, or in case of odd number, fractions, the whole number will be taken. Okay, so at any angles you apply this formula 360 by theta minus n 1. 360 by theta minus 1 is the number of images formed in case of two plane mirror kept at a particular angle theta. Clear? So now come, today I will discuss about the spherical mirror. Yesterday I have discussed about the plane mirror. Today I will discuss the spherical mirror. What is spherical mirror? And it is of two types: convex mirror, concave mirror. Spherical mirror. What is the spherical mirror? Yes, spherical mirror. It is the mirror whose reflecting surface is a curved or spherical is called spherical mirror. Whose reflecting surface is curved or spherical is called spherical mirror. It is mainly of two types. One is convex mirror, one is concave. Concave and convex mirror. In case of the lens also, I also apply the term concave lens and convex lens. Okay, so this is the plane mirror. So if the reflecting surface, this is the part of the sphere, it is concave. What is the definition of the concave mirror? If the reflecting surface, that is the, what you see in the mirror, there is the silvery surface of there. When I look in the plane mirror at home, what do you see? There is a glass, and behind the glass, what is there? There is the silver surface protected up there, so the light cannot pass through it. The light being reflected. That is the plane mirror. This is the reflected. This is the silver surface. Light out here. Light here. Light incident. This is normal. This is reflected back. And there is a silver surface out there for the reflection. The plane mirror. In this case, the concave mirror is the part of the spherical mirror whose reflecting surface is the inner shiny surface is the reflecting surface. Inner surface is the reflecting surface. Outer bulging is the silver surface. That is the concave mirror. Just see, this is the spoon. This is the inner surface. This surface. This. If this surface is the reflecting surface and this is the silver protection, so this type of mirror is known as concave mirror. Concave mirror. And opposite, this is the bulging surface, the outer surface It is the reflecting surface. This is the convex mirror, and inner is the protection by silver protection. So this is, in this case, this is convex mirror. This is concave mirror. This is the reflecting surface. That means if this is this, so if this is silvery surface, so inner surface, this is the reflecting surface, light passes there and it will out, reflecting surface out there. This type of mirror is known as the concave mirror. And when this bulging surface, this is the reflecting surface. This is the reflecting surface, and inner is the silver surface. This is known as convex mirror. Okay, and how the reflection takes place in these convex and concave mirrors, I'm discussing now. But in case of lens, what we see after that, in case of mirror, the light will not pass through the mirror. Okay, never pass. It will reflect back, the bounce back, concave or convex. But in case of lens means plane lens, plane surface, plane lens. Glass is a lens. Light will pass. Lens, light will pass. Light will pass. Okay, this is the difference. But here, do not pass. It is reflect back. And in case of lens, I will discuss later about the lens in the next class. So now I am discussing the important part of the convex or concave mirror, that is the spherical mirror. So what is this thing? What is the center of curvature? What is the radius of curvature? What is the aperture? What is focus? What is pole? What is principal axis? What is focal length? All you should have to know. And it is very helpful for the drawing so many images in this mirror, or also lenses. So what is the principle? What is the center of curvature? What is center of curvature? Center of curvature क्या है? It is the center of a sphere. Center of curvature, the center of sphere of it is a part of a spherical mirror. Okay, it is denoted by C. That is the center of curvature. It is denoted by C. So in this mirror or in this mirror, this is the center of curvature denoted at C. Any. This lens also. Okay. So if this is the center of curvature, C. The part of the center of sphere is a part. Okay. Then radius of curvature. What is radius of curvature? So as it is a sphere, it is spherical. The sphere there must be radius. As this is the center and this is the radius. So the radius of sphere is known as radius of curvature. As it is spherical in shape, it has center, so it must be radius. So radius of the curvature, that means the radius of the spherical mirror is known as radius of curvature. It is just denoted as R. Just the distance of this is the radius of curvature. It is denoted R. Clear? Then come to the pole. What is the pole? This is the pole P. It is denoted as P. So what is pole? The pole is the geometric center. The geometric center of the sphere, the spherical surface, the geometric center of the spherical surface. Geometric center of the spherical surface of mirror is known as the pole. It is the midpoint of the aperture. It is the midpoint of the aperture. Okay? And it is denoted as P. What is principal axis? Principal axis. Principal axis is the line joining from pole to center of curvature. If you join a line, this. So this is the principal axis. Straight line joining through pole to center of curvature and extending. This is known as the principal axis. The PC. It is the principal axis. Okay. And what is the focus? Focus and focal length very important. When some ray of light After passing focus, what is the focus? Suppose this is this is the principal axis, this is center of curvature, this is suppose focus. I will not indicate that. If parallel ray of light, it after reflecting, it will reflecting out here. Another ray, it will also reflect back. It will also reflect back. Parallel means reflect back. Reflect back. Again, this is also ray of light. It will reflect back. What do you see out here? The parallel to the principal axis, some ray, when it strikes the mirror, it returns back and meets at a point on the principal axis. Meets at a point on the principal axis. Okay, all the ray meets at a point. This point is known as the focal point, the focus point. The length between the distance between the B and C. Okay, focal length, distance between this and this is known as the focal length, which is denoted by F. This is the focal length P to F. Is the F focus. That means in case of convex mirrors, concave mirrors, or convex mirrors, parallelly or principal axis passes through a point on the principal axis. That point is known as the focal point. Okay, this is the first focal point. Clear? So focal point and distance of the focal point and the pinpole is known as the focal length, which is denoted as F. Clear? Now, these are rules why this parallel ray comes and meet. I will discuss a little bit later. Center of curvature, radius of curvature, aperture, focal length, focus or first focal length, optical center, all have been discussed. And you have to remember the three things in case of reflection of light through mirror. What is this? The four things. If what do you know? Center of curvature, focus, principal axis, pole, radius of curvature, all you know. So four things. Suppose this is the concave lens. Suppose so this is principal axis. This is center of curvature. Okay. This is focus, focal length. This is center of curvature. This is principal axis. Clear? So if when some ray of light incident parallel to the principal axis, what will happen? See what will happen if this is the principal axis, some parallel ray of principal axis, this is the parallel ray of principal axis, incident in this point, it always passes through the focus, always. And this is any light parallel to the principal axis is always passes through particularly the focus. Anywhere in this way, it will also pass through the, always return back to the focus. This is the one rule. If any ray passes through the incident to the mirror, concave mirror, parallel to the principal axis, it always returns to the focus. Consequently, the converse in case of if any ray passes through focus, suppose just give the direction. If this is the ray which passes through focus, it will return back parallel to the principal axis. A ray passes through the focus, it will come out, returns back, bounce back parallel to the principal axis. Principal axis parallel incident, return back to the focus, and incident to the focus, return back parallel to the principal axis. And if 2 points already discussed, if a ray number 3 passes so from out here through the center of curvature, that is through this, if a ray passes through this in this way, so it will return back in the same direction. Okay, it will passes, it will return back in the same direction. Clear? If a ray of light passes through the pole, if it is passes through the pole, okay, it will return back obeying the law of reflection of light. This is I, this is R. If it is incident to the pole, then it will return back towards this. It is normal. This is the I. This is R. So this is the condition. So many conditions in case of convex lens also and concave lens also. Same thing. In case of concave lens, what will happen? Nothing will happen. In this case, it will come out here parallelly. This is the bulging things. This is the pencil axis parallel. It will not go there. It will return back. I mean, if this one, it will be out this. So this will return back. This will not out there. This will return back. Okay. This will return back. Return back. Okay. So parallel ray of principal axis, incident, and it will passes through the focus. And focus, okay, and through the focus, when it passes through the focus, it will return to the parallel to the principal axis. Okay. So you will remember it. Start the different images formed at different position. Mainly 6 positions are there. It will be enough for you. Suppose when the object is at infinity, what will be the size of the image, nature of the image, position of the image? It is beyond center of curvature. It is at center of curvature. It is in between the center of curvature and focus. Center of curvature and focus. It is at focus when the object is at focus, and when the object between focus and pole. This is the pole, this is the focus, in between this. So 6 positions are there. And it is enough for you in case of lens also, and also mirror, concave or convex. So now let's discuss one by one. Suppose an object AB, it is situated at the infinity, That where the image will form, you should have to find out. What do you see out here? From the infinity A and B, a ray of light, it is passing through the parallel to the principal axis, so it will pass where? From the focus. And also the ray is passing throughout the parallel to principal axis, it will also pass to the focus, and they meet at F. So the object image will form out here. It is highly diminished. That is real, diminished, and point sized. Clear? So when the object is at infinity, the image will be very diminished, highly diminished, and it is real. okay, and in front of the mirror. Clear? So in this way you have to draw it regular basis, and you will easily can be easily give the answer. What is the object image? What is the size of the image? Nature of the image? And you should have to practice it. Nothing else. Suppose an object is a center of curvature. An object is a center of curvature. So what will be the image? Suppose an object, it is center of curvature. It is there. Clear? So what is the rules? What is the rules? It is if a parallel ray pass through the principal axis, it will pass F. Okay, so it will pass through focus. Clear? Again, another way, if it is pass through the focus, it will pass parallel to the pencil axis. Okay, parallel to the pencil axis. This never forget to give the arrow sign. It indicates the ray of light. Same. Then focus. It will return back parallel to the pencil axis. Okay. It meet out here. Okay. That means point out A. Out here A dash. Okay. This is the image size, position of image. An object which situated at center of curvature, image will be at center of curvature. Clear? Image will be at center of curvature. Okay? And size most probably the same. Size of the same size. Clear? Same size, inverted, and at position center of curvature. Has it given? Okay? Look and go through your book and then practice all these things. Okay? The center of curvature, the object and image will be center of curvature. Okay? Image will be same size. Okay? Same size. So it will be very easy to draw if we have to practice by drawing it. When in between C and F, object is C and F, that means out here, object is out here. Object is in between means यहाँ पे कोई भी प्लेस में होगा, यहाँ पर हो सकता है, यहाँ पर हो सकता है, anywhere you can draw it. Same process, same thing. Okay, you have to draw it. Now I am discussing also another thing. Suppose that F when the object is at F. At F, focus, object is as focus, or in between focus and pole. Where will be its image from? Where? Focus? What is the focus? Out here is the focus. Then same thing, if a parallel ray up to the principal focus passes, object is at F, in a focus. When object is at focus, so where will be the image and nature of the image? See out here, if a ray from the parallel axis, parallel to the principal axis, okay, it will go from always at focus. It is always at focus. This is, it will return back. to focus. Clear? And again, this is the pencil axis parallel. It turns back to the focus. And ray which is passed through the pole or which is passes to the center of curvature. Center of curvature, it will back to the center of curvature. Okay? A ray of light passes center of curvature. Center of curvature, it will returns back in this position. Okay? In these positions, where they will meet? They will meet at infinity. That means if object and image will be at infinity. Position of the object is at focus and position of image will be infinity. Okay? This is the size and this size will be enlarged. Clear? See? It is the focus, at object is at focus, image will be at infinity, size of the image will be smaller or greater? Greater. That is highly enlarged, not diminished. Clear? So this is the very important. And same thing will happen in case of in between focus and pole. You will have to draw it and practice it. In between P and F, it is pole and focus. The pole and focus, it will be highly enlarged. Highly enlarged. Okay, you will see pole and focus out here. Parallel ray, it will go towards the focus. Okay, then center of curvature, it will increase, and in this way, the object will be out here. Most probably, in this case, object will be out here, highly increased. Okay, so practice it, and anything, any doubts, ask me in my comment box. I will give you answers, and I also teach you some mathematical problems regarding this. Okay, after doing some images through lens, convex lens, concave lens, and also the glass slab, refraction. Then I will complete, then the chapter will be completed. Okay, so thank you, good night.